Hello everyone and welcome to another video. Today we're going to do some programming again. We're going to work on Hermes, my programming language. And I created an issue a couple of minutes ago. Add and implement assert statement. An assert statement is basically saying that you're expecting some kind of behavior, right? So that's basically what I'm going to implement. I don't know if you have used Python, but in Python you can do something like this. Assert 1 is equal to 0, and you're going to get an assertion error, basically. And the program will stop. So I'm going to implement this in Hermes. So let's go to the project. Whoa, I'm just going to make my webcam follow. There we go. And we're going to open up the editor. And we're going to see if I have any changes. Yeah. Let's just do okay. So let's do this. When I implement the assert statement, I think we should go into the parser, because here's where I have the other statements. And yeah, we can add it here actually. Const char statement assert is equal to assert. And then we're going to see where I'm using the other statements. All right. So we're just going to do and add it here as well. This is within the statement parse function, which makes sense if token value statement assert 0 return Hermes parser parse assert parser scope. Now obviously this function doesn't exist yet, so I'm gonna have to implement it. Let's see where we have the parse iterate. Let's just add it below this one. Hermes parser parse assert. Hermes parser t Hermes parser Hermes scope t scope. And then of course we're gonna implement the function as well. Parse iterate. There it is. Just add it here. Let's put the editor here instead so that we can see it a little bit better. Okay. So this one will be very similar to the parse new parser. So we can copy that one into the parse assert method. And we're still going to parse token ID because this is the statement. And then we're going to construct an AST here. Let's call it AST assert. And we're going to use AST assert. And that one doesn't exist yet either, so I'm going to have to implement that one. And then we're going to do AST assert assert, let's call it expression, is equal to parse expression. That's correct. The assert. Okay. Now what we have to do is to go to the est.age, and we need to add the assert here in the type enumeration. And we also need the expression. I think that's what I called it, assert expression. Yeah. Cool. So parse assert statement iterate. Cool. So we should be able to parse that now. Let's see if this compiles and see what kind of errors we get. No errors actually. Okay. That's pretty cool. So let's see if we can use the assert now. Obviously we haven't implemented in the runtime visitor, so it's not going to do anything, but let's just add assert.he. And we're going to, let's make a false one. So we're going to do assert 1 is equal to 0. And we're going to do execute that. Uncaught statement. Right, because it doesn't know what to do with it, but it parsed it correctly. So that's good. But the runtime environment doesn't know what to do with it. So if we can find the iterate thing here, we should add the assert underneath it. So we're going to tell the runtime what to do with the assert statement, basically. Assert iterate. Let's go and implement it. That's kind of weird that I'm having this function here. Oh well. So we have the visit assert. Let's just print something here. Print f. Hello. Or we visited the assert statement. And let's just return. Let's just turn no operation for now. Okay, and obviously we need to add it to the big chunk of the big switch statement here as well. So let's just copy that one, and we're going to do the est assert. So now we should, if we recompile and we run it again, we should see the print. We visited the assert statement. Cool. So now it's just up to us to do the appropriate thing here, I guess. I think I should have like a Boolean expression kind of, yeah, Boolean evaluation. Ist integer node. Boolean expression default. Okay. So what are we doing here? Basically, I'm trying to find how we should determine, or how we should parse the Boolean expression, basically. But I think it's going to see if we have like an equals. Yeah, token equals. So it's going to be a bin operation, binary operation. And it will return, it's going to return a Boolean, isn't it? So like equals. Yeah. So we have some kind of Boolean parsing here. So if we go into the assert here again, I think what we can do is basically ASTT Boolean result is equal to Boolean evaluation runtime visit runtime node. So this will be, actually this is not going to be an AST, is it? This function does not return an AST. Boolean evaluation. No, it returns an unsigned integer. Okay, cool. Yeah, so we can actually just use that function. So if if this evaluates to false, if the assert evaluates to false, then we're going to die actually. Runtime. Do I have like an error function? Hermes parser type error. I'm thinking I should have some kind of error function here, shouldn't I? Apparently not. Yeah, we don't have a good error system yet in Hermes. So we're not going to get any line numbers or anything at the moment. I have to implement that another day, I guess. I am not going to implement it in this video. It's going to take too long time. It's a bit complicated. But anyway, if the Boolean evaluation evaluates to false, then we're going to say assert failed, and we're going to die. Otherwise, we're not going to do anything. Basically. I'm thinking, should I return true here? No, it shouldn't return anything. An assert statement doesn't return anything. At least from what at least as far as I'm concerned, but oh well. So if we compile this and we run this, we're getting a segmentation fault. Well, that's not very good. Okay, so let's see why that is happening. Actually, let's recompile everything because it might be a bit broken because I've changed some header stuff. Yeah, it's still we're still getting a segmentation fault. Runtime visit assert runtime.c 1479. Oh right, we're creating an infinite loop here actually, because we're visiting the assert statement again, so it's just gonna keep calling this function over and over again. What I need to do is visit the expression. So I want to do what did I call it? Assert expression. That should do it. So if we recompile it and we run it, we're getting the assertment failed. So if we that's pretty good. So if we go into here now and let's just print asserting 1 equal to 0 and above it, we can make another assertion that is going to be true. So let's just do assert 1 is equal to 1. Print asserting 1 is equal to 1. Just print okay. Print okay. And if everything works correctly, we should never reach the second okay. We should only get one okay. So let's see that. Yeah, we're only getting one okay. Cool. So the program has died after this false assertment here. That's what I wanted. Now, I haven't really solved this in the correct way because we're not getting, at the moment, we're not getting like any kind of information about why this assertment failed. What you usually want is like maybe the interpreter is going to tell you what the difference here is. So the best case scenario here, the interpreter would tell you that, hey, 1 is not 0, basically. But at the moment, I think it's going to take a pretty long time for me to implement that because it's a bit complicated. I would have to go into the expression, look up what kind of expression it is, and if it's a bin operation. Actually, it's not that difficult now when I think about it. I could probably make a function that is used to print a bin operation or turns a binary operation into a string or something. That could be one solution to this, actually. So first, before I do that, I want to move a function. I saw that a function was a bit misplaced. I think it was the get scope. Yeah, this one is like in the middle of everything. It's pretty weird. Let's put it. Usually I put like the helper functions at the top of the file. And this is a function that is used a lot, so probably gonna have it at the top. Makes sense to have it there. Now, I need some kind of function to turn a binary operation into a string, so to print it. But maybe to solve this correctly, the AST struct should have a way to turn itself into a string. That would make sense, because then I would change the print function as well. Maybe I won't do this in this video actually, because there is a lot of work now when I think about it. So for example, in the built-ins, we have the print function. It's like very simple at the moment. Here's the built-in print function. When you print something, it just there's a switch statement on the type. If it's a null, it just prints null. If it's a string, it's print the string value. If it's a character, it's print the character value. And yeah, the list goes on. But to replace this, I could probably have another function inside of the AST. The actual AST node, like a toString function or something. So the AST knows how to turn itself into a string. And then I could easily create a function that turns a binary operation into a string so that I can print it out on the screen and tell the programmer what assertment has been, what assertment is failing, and the difference between the left-hand side of the assertment and the right-hand side of the assertment. Because then I could recursively visit all the nodes in the expression after the assert statement. So basically, if I go into the assert here again, for example, if I would, let's say I declare like a variable, let's say we have int x is equal to 5, and we have a function int get number, which return 8 or something, I don't know. And then we have an assert statement, assert x is less than get number. So in this case, if I wanted to inform the programmer what is, actually this will assert true, let's just do this. If I wanted to inform the programmer on what's, what the assertment is, why the assertment is wrong here, then I would have to recursively visit the nodes to the right here. So first of all, we're going to encounter a bin operation with where the left hand side is a variable, and we're going to visit that variable, and eventually we're going to find out that the variable contains the number 5. Okay, then we're going to go back, and we're starting over at the binary operation again, and we're going to visit the right hand side. Okay, we're going to see that it's a function call. It's going to look up the function definition. It's going to visit the body of the function definition, and eventually it's going to encounter the 8. And during these recursive visiting operations, I would construct a string and print it out on a screen so the programmer sees why this is failing. And the optimal, another nice to have thing here is to actually see the line number of the failed assertment. But I don't have this. It's kind of embarrassing, but I don't have. You currently can't get the line numbers in the error messages because the parser doesn't track. The parser doesn't know anything about the line numbers, and then that information is like lost after the lexer has done its job. So I would have to spend some time on that. We definitely have to spend some time on that, but that's not really related to this assertment implementation, because this is like another issue. This is like an error reporting issue. So I should probably create another task regarding error reporting and start working on that in there. So I think we're done with the assertment stuff actually. So I should probably add a unit test for it as well. Right now my unit tests are a bit bad, to be honest. They basically just check that things aren't crashing at the moment. Let's add another test for assert. And we're just gonna do that. And we're gonna copy some code. Sources, and we're going to copy the file. Assert, we're going to put it here. Now, I want to assert that we're getting it, that it's going to exit. I don't know how to do that actually. So right now, I know this is a really bad test, but we're just gonna assert. We're just gonna in the test. We're just gonna assert that that using assert doesn't crash, basically. I'll have to implement better tests soon, but for now, this is the best I can do. Let's recompile and let's go to tests. And the tests are passing. I forgot to add this test actually. So we need to go into the main.c and we need to add it here. There we go. Now it's running it and it's passing. Cool. So basically all the tests are doing now is basically just testing that code isn't crashing, that the interpreter is still alive after using some methods. They're really bad tests actually, but I'm working on it. I'm gonna make better tests soon. What did I think of? What did I think about? I was thinking about something. Yeah, actually the tests in the lecture, they are actually the only ones that are kind of good, because they are actually testing the actual behavior of the lecture instead of just testing that things aren't crashing. Okay, but anyway, let's push this. Let's make a separate branch. Let's call it assert. We're gonna do git add all, git commit and we have a number on this task, 43. Implements assert closes 43. Git push set. Oops, assert. Okay. Then we're going to make a pull request, and my checks should be running. Let's just create it. It's running the unit tests. I think we can see it here. And the job was completed, and I should now be able to merge pull request, confirm merge. We can delete the branch. We can create a new issue here. Show line numbers. Show line number in error messages. Labels. It's pretty important. I guess it's a good first issue. And it's an enhancement. And then I'm going to add another issue. The AST should be able implement toString method for AST. Yeah, I think that says it all. The AST should be able to turn itself into a string. This makes a lot of things easier. For example, cleaning nodes or turning or Enhancement. Yeah, that's it. New issue. Show left hand versus right hand diff on failed asserts. For example, assert 1, 0 should print why it fails and the difference between the right hand side and the left hand side. Labels. It's an announcement for sure. It's probably a good first issue. Submit. And I might even add them to the project board. So let's add it to here. How can I find them? Show line number in error messages. And something like that. So that's it, guys. Thank you for watching me implement Assert in my programming language. I hope it was interesting, and I'll see you in the next video.